Isn't it incredible? It's already week 10. I hope you enjoyed the course so far. We started off analyzing data and just describing it using graphical types of techniques and also numerical types of techniques. Then we moved on to the phase 2, where we actually draw a sample and do something called an inference, where we infer what's going on in the total population by just looking at what's going on in a sample. We've made a few observations, and that is, if the sample size is bigger than 30, it doesn't really matter what the underlying parameters of the population is. However, if it's less than that, we need to make some assumptions and say it's normally distributed. So sometimes we have to test for normality. We assumed for the rest of the analysis this normal or the central limit theorem. We then looked at ways of estimating the average or the mean within a population, and we say that we do by just calculating the mean of the sample, and there's reason to believe that will be the same as that of the population. We did some further calculations so that we can actually put boundaries, and we focused on something called assuming a t-distribution as opposed to a normal distribution, because we accepted that in most cases the standard deviation will not be known. So we want to estimate the standard deviation by calculating the standard deviation within the population. We then looked at describing one population, and then we looked at describing two populations and comparing them with each other and test whether the mean or the average is different in the two populations. That's what we did last time. Now, there's an ever-increasing demand to simplify what you say in this world. So people often want a yes and no answer. Now, if you know anything about statistics and probability, it's very difficult to say yes or no. So the answer that we're going to look at is something called hypothesis testing. Hypothesis testing is giving a question, is the answer yes or no? In the formal world of hypothesis testing, we want to say something like, with 95% certainty, it is true. Or with 95% certainty, we will reject the null hypothesis. In the case of, for instance, a court case, which is something that you should always bear in mind, there's a null hypothesis that you are innocent till proven guilty. And the judge will reach a verdict and then say, this person is not guilty. It's interesting that he says he doesn't say the person is innocent. He says the person is not guilty, or otherwise he says it's guilty. So the null hypothesis in the case of a court case is guilty until innocent until proven guilty. The null hypothesis is this person is innocent. Now we want to show a little bit of how do we draw that type of conclusion with 95% certainty. We can decide up front we want to do it with 90% certainty and so on. So that is what we're going to look at. In this particular chapter, I've linked a couple of videos that will hopefully help you understand it even better. Let me know what you think of the videos. Hope to see you in class.